very good morning. So we are discussing with respect to unit number 4. In last class we have discussed about photoconductive and photovoltaic. I think I have told in last class itself, in syllabus they are confusing. Photoconductive is same as photoresistive and it is same as LDR. All are same. Okay, only difference is I have told there is photoconductivity and photovoltaic. Photoconductivity is, this is just a recap. Photoconductivity is nothing but a PN junction diode in reverse bias condition. So normally it will offer very high resistance, and if this light falls on this, there is obviously that photons get observed and that resistivity comes down. So in photoconductivity, a PN junction in reverse bias. Next is photovoltaic, is again same PN junction but is in forward bias. So from the sun you receive photons, and this photon will fall on this particular PN junction, and the energy from the photon is able to break the barrier and make the electron to flow. Okay, so let us today discuss about fiber optic sensors. Okay, so fiber optic sensor, you can see here we will have a light modulator. Light modulator is nothing but like a mirror like structures. So there will be an input light, and input light will be made to fall on an object which we are going to sense, and that light will get deflected. So from the deflected light I am able to make that object. What is the object which is there? Okay, usually light sensors are used for measuring variation in temperature, variation in object size. Okay, so basically it can be physical or chemical or biomedical. For this three different types of various inputs, we try to use this fiber optic sensors. Okay, so fiber optic sensor is a sensor that uses optical fibers as a sensing element. The basic component are simple. Light is taken to modulation region using fiber and modulated through physical or chemical phenomena, and the modulated light is transmitted back to the receiver, detects and demodulates. So that is what the basic of fiber optic sensor. There are two types. One is called extrinsic fiber optic, another one is intrinsic. In extrinsic fiber optic, it is nothing but the ones where the light signal modulation occurs outside the optical fiber and are delivered to optical fiber. So that signal modulation is done outside the fiber optical. So fiber optic is just used to carry the light wave, that's all in case of extrinsic. So fiber, the light transmission depends upon the alignment of fiber core, that is input fiber core and output fiber core. The light is detected by light detector. Any deviation in fiber pair from perfect alignment immediately sensed by the detector. So this is what we call for extrinsic. Whereas in intrinsic, you have a circle, inside that itself you try to allow. So word itself is very clear. So in intrinsic sensor, the physical parameter changes. Some characteristics of the propagation light beam that is sensed here, the optical fiber itself works as a transducer, where their optical fiber is not used, where here it is used as a transducer. So only a simple source and deduction unit is required in case of intrinsic. There is no complication. Okay, let us see application for both. So Mach Zehnder interface metric sensors, this was the first developed. This is an extrinsic type. So here you can see you have a light source. From that light source it has been reflected. This is the object which you are going to sense. So you will get both refracted and reflected image on the screen. So from the screen I will be able to identify the various intensity levels. Okay, so interferometer is a most sensitive arrangement for optic sensor used when extensive sensitives is required. Okay, a complete beam is passed through the fiber optic coupler which splits the beam into two equal amplitude. Two beams are then passed to the second mirror through two arms. The output from the second mirror enter the two detector where they are sensed and detected. So this is how you try to use light source to identify the object. So you send the light source, based upon the intensity of the light being observed, the remaining part of the light get travels. That is the main idea behind it. So something is been observed and something has been relieved. So it is something like X-ray, whereas in X-ray it tried to pass through the object. Here not passing through is not possible. So wherever the light has been observed totally, where you get a black image, wherever you get not a little bit dull or even like grayish, where the light has passed through. Okay, so this is the particular case. And when I take mirror of this, wherever it is dark, that will become light, wherever light, it will become dark. Okay, so comparing this two, I will get an idea of what is the images. So this is what extrinsic, where when you go for intrinsic type, we call it as gyroscope. So it will like to compress and expand. So this compression and expansion, we will try to measure the object. So that is called as the second type. The principle of operation of fiber optic waves is based on Signac effect, the sense, the orientation. So it will try to rotate and try to compress, the performing the function of mechanical gyroscope in electrical, and whereas mechanical is there. Mechanical is there when there is any moving part, we call it as mechanical. Due to Signac effect, the beam traveling against the rotation experience a slight shorter path delay than the other beam. The first taken by the beam, and the difference in the phase shift result in change in intensity, which is measured. Okay, now let us move on to the second topic, which is called as pressure measurement. Okay, when you say measuring of pressure represented as force per unit area, usually always pressure has been represented as force per unit area, restricted to fluid, because fluid you cannot measure pressure, because they itself will expert some amount of pressure, and when there is change in pressure, it is difficult. So this type of measurement is not used for liquids, because in liquids you have a different type like flow meters, even that is there in our syllabus, we will see. So this is not meant for liquid. So usually pressure measurement we go only for air medium. Okay, these instruments are used to measure gauge pressure. That is what I told. I think you might have seen this, like when you go for filling up air in your cycle tire or two-wheeler, they will have a big container where they store the air, and near that you will have a gauge like measurement. That gauge will tell about what is the pressure inside the particular tank. Okay, the pressure, that meter is alone, we say it as pressure meter. That gauge what you see with the needle that we call it as pressure measurement. Okay, the pressure is the force applied perpendicular to the surface of the object per unit area over which that force is distributed. So inside the cylinder you fill the air, you go on filling, and thereby it increases the pressure. This increase in pressure will exert a force on the measuring device, and that measuring device we call it as pressure gauge. Okay, first one is diaphragm. Diaphragm itself is nothing but it is like a thin material, elastic material. So when the force is applied, this elastic material will try to elongate. So amount of elongation we will try to measure. Again, you can have both mechanical as well as electrical. So in mechanical you should have like a spring like structure which will try to measure it, and you have a well-known person called LVDT. So the amount of this elastic material movement is read by an LVDT. So diaphragm pressure gauge uses the elastic deformation of diaphragm, that is member, instead of liquid level to measure the difference between the unknown pressure and the reference pressure. So this is the instrument which you might have seen. Always the pressure in terms of bar. So here you will have an inlet. So the tank air or the air which is stored in that particular tank will also go in this particular valve, and this will enter a pressure of diaphragm. Okay, here it is the diaphragm, that is the elongation material which I have told. Then comes your mechanical part, and this needle will try to show. I will even explain. See, this is how this, we call it as diaphragm, a thin membrane. I have an external pressure, I have a reference pressure. Reference pressure is just what is the pressure in this area. This is not vacuum. you are not supposed to make it as a vacuum. You will keep some air pressure here, so that we call it as reference. And if this air enter here, this will try to deform this particular thing. You can see here. So from upward, if the pressure is there, then it will try to elongate in this direction. So now this was initial and this is changed. So difference is nothing but will give you about the pressure of this particular person on this diaphragm. Okay, so how you are going to measure this? You can put an LVDT. LVDT is we have seen. So it is LVDT. So you place it LVDT here. So once this fellow try to move down, automatically this will also move. Here you will have two transformers. When there is movement in this mechanical, there will be electrical change, and that will be noted. Okay, so this is how diaphragm is working. A typical diagram pressure gauge contains a capsule. Capsule is nothing but as a place where you place this. So this is called a capsule. This entire structure, this we call it as a capsule. This capsule, you have a diaphragm here, one inlet for external pressure and one for reference, or we know what is the pressure inside that capsule. Divided by a diaphragm as shown in schematic. One side of the diaphragm is open for external target pressure, that we call it as PXCT, and the other side is connected to a known pressure or P reference. The pressure difference between P external by P reference will give you the mechanical deflection. That mechanical deflection you can directly give it to mechanical movement or electrical conversion. If you want, you can do. The membrane's deflection can be measured any number of ways. That is what I told. See this part, this is diaphragm you have. So external pressure, this is going to move. So this movement, okay, after this you can do it by different way. Okay, for example, it can be detected via a mechanically coupled inducting needle and attached strain gauge or linear variable differential transducer. So first part will give mechanical output, second part will give electrical output, or the way another displacement velocity sensor. Once known, the deflection can be converted into pressure loading the plate theory. Okay, now there are advantage and disadvantage. This is much faster and good response, good for low pressure. You cannot keep this membrane for very high pressure and all, then that will get damaged, so that cannot be done. So it is good for low pressure. Then higher over pressure safety used for measure gauge, atmospheric and differential pressure. Difficulty is more expensive for high pressures. Okay, so this is the structure you can see here. Now I am giving the inlet air here. So depending upon the air, this will try to move upward or downward. When the pressure decreases, it has to move down. If pressure increases, it has to move up. So to come back to the normal condition, we have something called spring. Okay, and this is the entire case, and this is how the structure has been there. Now when this moves up, automatically this will try to move this pointer, and this pointer will point in the scale, and to come back to the pointer to the normal, you have a spring. Okay, spring like structure, so that will bring back to its normal. And for weight adjustment, you will have another end. So this is to adjust such that it has to be calibrated. Okay, so this is how it will be. And this setup we call it as Bellows pressure gauge. An 8-mark question can be asked. They have separately mentioned it. Okay, so instead of diaphragm, now we have kept a mechanical structure like this. Okay, so this is how it will work, and this air should not enter the spring and all, so that you will have a structure here. You can see here, this is like a membrane structure. This membrane will compress once the spring get compressed, and again it comes back. Okay, so that we call it as Bellows. This structure alone we call it as Bellows structure. where when air enter, this try to compress. It is like a diaphragm. Bellows are also used for pressure measurement and can be made as a cascaded capsule. The basic way of measuring is by fastening together many individual diaphragm. So this is like 2 or more, 3 or 4 like diaphragms, they are cascading. The basic manufacturing of bellows is by fastening together many individual diaphragm. The below elements basically is one piece of expansible, collapsible and axial flexible member. Then construction for individual purpose, the commonly used elements are by tuning form a solid stock of metal, by soldering and welding stamp on angular rings, rolling a tube, by hydraulic form of drawing turbines. Okay, then what and all can be done is for selecting a specific material for elastic member like bellows, the parameters are range of pressure. To what range I can measure. What is the hysteresis? Hysteresis is nothing but the permanent deformation which is occurring in my member. See, even though you say elastic, even your rubber band, you know, if you try to elongate and keep the rubber band for a particular duration of time, then if you release it, it will not come back to original. It will have some amount of elongation which has taken place, that we call it as hysteresis. Then about your dynamics, then your corrosiveness, because there are some metals in our ocean, they gets corroded. Then fabrication is how to do easy fabrication, and sensitivity to fluctuating pressure. If the pressure is not constant and if it is fluctuating, then now you are going to use your sensitivity. Then working, that is very simple. Working, just from the bottom you try to allow the inlet air and it will try to compress with the help of spring which has been connected to the displaying unit. And now you can see here, that is same thing we have just drawn and shown you. This is to going to the pointer. This is for 0 adjustment, so I can do some adjustment for 0 and try to bring the pointer. So 0 direction, this will come down or up, just to adjust it to 0. Okay, in one method spring is kept inside the diaphragm material. In another type, spring is being brought outside. See, this two, there is a difference. Here spring is there inside your diaphragm material, here spring is being brought outside your diaphragm material. Okay, so that is the two different types. The flexibility of the metallic bellows is similar in character to that of helical coiled compression spring up to the elastic limit of bellows. The relation between the increment, see, there are two different way where you going to use this one or this one. So depending upon the application, we choose whether you want to go for compressive type or expansion type. Okay, and now let us move on to the third topic for today's discussion, is which is nothing but piezoelectrics. So piezoelectric, now this is totally an mechanical to electrical conversion, where previous and all we told you should have a diaphragm and this diaphragm should move up and down and movement of diaphragm should be noted. All that is required, whereas in case of piezoelectric, a single mechanical structure will be there. If you compress this, you will get an electrical output, generation of electrical potential in response to the applied mechanical stress, derived from a Greek word piezo, meaning squeeze. When you press, okay, that is called piezo. The transducer convert one form of energy to another. Here transduction is from mechanical energy to electrical energy. Many piezoelectric materials are well known, but the more popular one is quartz. Okay, remaining are even some man-made are there, but natural is only quartz. The piezoelectric effect was discovered in 1880 itself. Okay, so we can see some applications where we use piezoelectric. So when you see in our human, so they try to read the pressure of your blood flow using piezoelectric. From there signal is being brought. Similarly in cell phone and all, you use piezoelectric effect by touching. When you touch, then by with the help of pressure you are giving, then we will try to do. And here you can see in sophisticated cars, I think you will read in upcoming semester a paper called embedded system, where nowadays automobiles are totally embedded, which means they are totally censored. Everything is being censored. Even now you can see when you sit on your automobile, it will ask to fasten your seat belt. Okay, previously it is there only for the driver seat. Now the next to the driver seat person also should wear the seat belt, and if he is not sitting, then the piezoelectric material on the chair will not detect any person, and it will not give any indication that put the seat belt. But if a person sits on that particular chair next to your driver seat, if a person sit, then automatically the piezoelectric placed on that particular chair will try to sense that someone is sitting on it, and it will ask to fasten your seat belt. Okay, similarly, like if there is any collision is occurring, then airbag has to release, and this airbag release is being done with piezoelectric material. So normally piezoelectric will be there, so if any object comes and hit, so you will get a mechanical, so you will get a compressive force, and that will release all the airbags in automobile. And even so many other things also uses this piezoelectric. Nowadays your automobile industry vehicle, even your tire pressure is being read. It will be displayed in dashboard, so it will say front, rear, two wheels, left wheel, what is the air pressure, there is a chance for puncture, please check, air pressure is very low. How it is being done is piezoelectrics are placed inside the tire. Between the rim and the tire we place piezoelectric. So what is the force which is being exerting? If the air is less, then less force will be exerted on the drum. Assume like you have a center drum over which you have a tire. So on the inside of the drum and below your tire we place piezoelectric crystal, and so there will be air pressure from your tire to the rim, and if this air pressure reduces, it will give intimation that what is the condition of that particular thing. So that is the case here. And there are so many valves and actuators who works also with piezoelectric effects. Okay, then comes your submarine. In submarine the outside pressure is more important. Like when you go under the sea level, the pressure increases, and the outside pressure is very very important because to handle our pressure. Okay, even you might have heard this, like divers, the person who go under the deep under the sea, they usually get affected due to hearing problem, because inside when you go inside your water the pressure increases, that will affect your ears. Similarly our submarine outer surface will be affected, so that we will constantly measure what is the level, whether it is there within our limit. Okay, so all these are the applications of your piezoelectric. Then we move into something like called as generation of power from our shoes. So in your shoes you can try to keep piezoelectric materials. So try to arrange it like this is outer rubber, inside layer, this is outer structure, and your piezoelectric crystal above which you try to place something like which is going to compress and give you the force. This entire has been brought here. So structure consists of rubber cutout, polycarbonate plates, copper terminals, and you have piezoelectric person. When stress is applied around the heels, electricity is generated. The power generated is order of few microwatts. Okay, but there are some application requires few microwatts. So for that we will try to use. Again I will say MEMS. We will see on this chapter what is MEMS later. Okay, which is nothing but fabricated electronic circuits which requires low power. That's all. Okay, that low power you can supply from your shoe itself. Then the airbag I told, collapsible steering. This is steering. When there is any force, then this should not come and hit the person who is driving. So airbag has to be released. So this is the compressed airbag, which is not normal condition. When there is exerted force, then this will try to activate and this will get blown, and you will have an airbag structure like this. Then this is what I told in tires. You try to place piezoelectric in order to measure the pressure of your air inside your tire. Then again in aeroplanes we use, in your aeroplane wings we use piezoelectric in order to measure the air pressure, outside air pressure. So based upon the outside air pressure, this will try to elongate. I think if you have traveled in aircraft and if you have taken a seat above your wings, you can see at the time of landing and at the time of takeoff your wings size will increase or decrease. So that elongation of your wings is you cannot do in your own way. We will measure the air pressure and try to elongate your wings. So, okay, so there we use piezoelectric. Then in fuel injection sensor, nowadays multi-point fuel injection system is there. So multi-point fuel injection is there is no inlet valve or outlet valve and all inside your cylinder. I think you know there are two types, internal combustion and external combustion. In internal combustion, external combustion is only steam engine. Nowadays we doesn't use any steam engine and all, so that is totally ruled out. We use only internal combustion engine. In internal combustion engine there are two types, one is petrol and another one is diesel. In petrol engine what happens is, initially the cylinder you have to evacuate all the exhaust gas, then you will try to open the inlet valve. So once the inlet valve is open, air mixed with petrol will enter, okay, and this will enter the cylinder. Then what will happen is we will try to compress. So once this compression starts, in petrol engine, if it is 100 cc, there is 1/8 in reduction in size. So if 100 cc, till what we will compress is, we will compress and make the volume as 1/8 of its initial volume. So if it is 100 cc, we will compress we will make the cc to 20. Till that we will try to compress. At this very high compression, I will try to ignite the petrol with the help of spark plug, or just it will spark there. So your petrol will burst, and you are thereafter you know that power is more than sufficient to make the cylinder piston to move down, and you get a rotational motion thereby, okay. But nowadays I don't have inlet valve, outlet valve and all. Instead I use piezoelectric material to measure the pressure, and if the required pressure is reached, then I will ignite with the help of spark plug, okay. This is in case of petrol engine. Whereas in diesel engine, what we do is, inside the cylinder we will supply only air, and we will not supply diesel, only air is being supplied initially. Then we will start compressing. There it is 1/16 of its initial volume, okay. That is why we say diesel engines are, you see more vibrations, and the temperature of the engine will be very high as compared to petrol. But the power developed by diesel engine is more. That is why very ICC vehicles are diesel vehicles. You don't go for petrol. So what we do is, we compress the air to 1/16 of its initial volume. At this very high compressed condition, we try to spray the diesel. Here we don't have any spark plug and all. We will try to spray this diesel. So very compressed air will have very high temperature. At that very high temperature, if I spray the diesel will burn, and then you get the power. So the thing you have to remember is, we sense the pressure by piezoelectric, and then we will try to give whether spark or diesel, depending upon the type of internal combustion engine, okay. Then we move on to last topic for today's discussion, that is, we call it as tactile sensors, which is nothing but how you are able to prepare a robot which is try to work like human. See, I repeatedly say, humans are nature. We cannot touch, because nature is nature. Whatever technology you develop, you are just 10% or 5% before the nature. That is because, see, when you have in your hand, when you try to touch anything, you will directly say this is plastic, this is metal. Just by touching with your hand itself, you will say this is plastic, this is glass, this is metal. All that is easily possible, and the entire skin itself is like acting like a sensor. It is not mandatory that at the fingertip alone, if you touch, we will be able to understand. Even at the center of the finger, or in the palm, or in the back side or front side, wherever you touch, we will be able to see. So that is where the nature stands. But when you try to do this with robotics, how you are going to do that? We call it as tactile sensors, or device that measure the information arising from the physical interaction with its environment. how does it sense deformation of. So till now what and all we have studied, that all type of sensor we try to put in that particular tip of the robot arm and try to do that. So you might have studied pressure sensor, you might have studied temperature sensor, you might have studied all type of sensor till now, all that will be put together. Okay, so when you take human, we are able to sense temperature, pressure, pain, everything. And when you say as kinesthetic sensation, again you go for body position, movement, equilibrium, everything you are able to do. All this we try to give it to robot, that we face so many consequences. And the strength of the human is large number of sensors, then anticipation. Drawback is non-linearity, hysteresis and low frequency of signals. Drawback is we are unable to do it on robot. That is what we call it as drawback, not drawback of human. It is drawback of our approach to reproduce human. So okay, when you try to reproduce human, we face so many problems. Like you don't have any hysteresis problem and all. Hysteresis means there is no permanent elongation in your sensor and all. When you touch you will sense, when you release you will release, then you will not feel anything. See, for example, when you go and touch an art object, only at the time of touching the art object you will feel the heat. When you remove your hand, automatically at next instant you will not feel any heat. But the condition is you are not supposed to touch for longer duration, so that it will get burned, your skin will get burned. Again there is no problem, it takes 1 or 2 3 months. After that, that skin will again come to its normal case. Again you can feel the temperature. Only till that 1 or 2 months you might have a burnt like problem in skin, and again it regains its to the normal level. So hysteresis problem itself is not there for our case. So this is what we are able to tell about the human sensitivity. If it is like 3 to 4 mm small, when you try to, it is like skin stretch. Then if it is DC to 30, you will feel a compressive stress. Then if it is more than 50 to 100, you will feel a vibration, and then you will have a directional skin stretch itself, so that we will be able to identify the object. So this how we try to frame the hand of your robot. So it is like a mesh like structure. So each and every mesh will form a different types of sensing element. See, this is, I have placed n number of meshes. So each and every unit will have a separate type of sensing. So one you can give for temperature, one you can give for pressure, and all such ways. So if this is mesh is used to measure temperature, then at some point you will have very high temperature, and some point you will have low temperature, and there is some medium temperature. So thermal image. So here when your robot goes and touch, then you will sense the temperature, and then you will get a thermal image, and we will try to reproduce what is the object which is being touched by the robot. Okay, so we go for mesh type structure. So each and every box is separate. So each and every box is going to be used for a particular type of application. So usually an array of discrete sensing elements can be of strain gauge, piezoelectric, resistive, capacitive. I think we have seen what is type of resistive sensors, capacitive sensors, then piezoelectrics, and other type like magnetic, optical. So in this mesh like structure, whatever sensing material you want, you can place it. So depending upon the application, whereas human is, there is nothing like application dependent. Human can do whatever job you want, but robotics cannot do that. So depending upon the application, you try to place the sensor, and then you try to form the hand of your robot. Okay, so this will be like structure like this. One side you will have a sensor, another side you have a receiver. So when you want to catch egg, then you have to expert a particular force. When you want to catch a tomato, then some amount of force is required for your arm movement in your robot. Wherever when you want to catch wood or iron, then more force you have to exert. So this is being done. Okay, by this way only we try to do. You will have a mesh like structure, try to sense it, then that is being given to this gear wheels. So based upon the pressure from here, you identify whether it is tomato, egg, or wood, or steel. Then based upon that you try to give the force, and then you try to hold. Then only the object will be properly hold. Whereas all this issues is not there for you. You know, when you catch tomato, you will have a little force applying on it. If it is egg, some more. If it is wood and all, you will try to exert more force. But that is how, this is how it is being made in robots. Okay, so with this we will stop for today's class. So in unit number 4, till what we have discussed is, so we have discussed till this. Okay, so in next class we will see about what is temperature sensor. So when in temperature sensor we will see what is thermistor, RTD, thermocouple and all. Okay, so with this we will stop our presentation. Okay, if some net issues is there,